Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to tutorials where you learn effortlessly. Now, if you haven't already, please subscribe to the channel and leave a like for this lesson. Today's lesson, we're going to look at a very interesting concept. And basically, we're looking at the factor and remainder theorem. I hope you can see it there. All right, so that is the factor and remainder theorem. And basically, this will be our startup for this topic, and we'll see how we go on from there. So if you haven't already, please subscribe to the channel and yeah, leave a like for this lesson. Like the video to support it. All right, so let's go. So for question 17, for each of the following, use synthetic division and division algorithm. So division algorithm, this is the long division that we've been doing. So that is division algorithm for the polynomials to show that g of x is a factor of f of x, and hence find all the factors in line or the possible polynomials. All right, so hence find all the possible factors of the polynomial. Okay, so we've been given this factor g of x is equals to x minus 3. We've been asked to show that it is actually a factor of this. So if something is a factor of something, then when we get that thing and divide it into that other thing, we should have no remainder. So that is the same thing that we're going to do for each of these questions. So to show that these are factors of this is a factor of this, we're basically going to divide this into this and that into that. So if it leaves no remainder, then we say it is a factor. But if it leaves a remainder, then we say it is not a factor. All right, so we are going to do this, first of all, using division algorithm, which is basically just long division. And I've started with long division because we have some ideas on how to use long division. So we are saying if we divide this into this, it should leave no remainder because it is a factor of that. So let's do that. So we're going to say the long division properly. So we are simply going to say, okay, we're going to say x minus 3 divide by 6x to the power 3 minus 17x squared minus 5x plus 6. So let me just x minus 3 there. Let me rewrite this properly. So that is x minus 3 divided by 6x to the power 3 minus 17x squared minus 5x plus 6. Now, how do we use long division? So the first step is our concentration will be this variable x there. And what we do is we get this x there, we take it into the first term there. So that is the algorithm. So we take this first variable of x. So you make sure that the variable of x is at the beginning here. Then you divide x into the first term here, which is the first x variable with the highest power. So we get the variable with the highest power. So here the highest power is x to the power 3. So we'll simply say, let me say this is 6x to the power 3 divided by this x. So we see that the x there and the x there simplify. We are going to have 6x to the power 2. So whatever answer we find by dividing x into there, we write it here. So that is 6x to the power 2. Okay, then what we're going to do is we're going to have this power or this answer that we found here multiplied by everything here. Okay, so basically that is the algorithm. So we say, we put it in brackets, we say 6x squared times x. So that would be 6x to the power 3. 6x squared times negative 3, that would be negative 18x to the power 2. Okay, then we subtract, we say minus. Okay, then we say all over, then we'll say 6x to the power 3 minus 6x to the power 3. So that is giving us a 0. Then we say negative 17x to the power 2. So we come to this part. So negative, let me write it here, negative 17x to the power 2 minus this minus the negative 18x to the power 2 inside here. So that is negative 17. This will be a plus 18x to the power 2. So that will be negative 17x plus this. So this is going to give us positive x to the power 2. All right. Then negative 5x, we don't have a term that has a x, which is just the x variable. And 6, we don't have a term that has a 6 here, so we can bring these down here. So these and this come down. So the negative 5x comes down and the positive 6 comes down like that. So now from here, again, the algorithm continues. So let me just simplify and let me just move myself so that you'll be able to see properly. All right, so I have put it where you can see it properly there. So again, the algorithm continues. We'll say x into the first highest variable there, which is the highest variable, which is x to the power 2. So we're simply saying x to the power 2 divided by x. So this and one of that will cancel and we'll remain with positive x. So we write the answer here, positive x. Then again, we'll multiply the positive x times x. So that will be, we put in brackets. So that will be x to the power 2, positive x times negative 3. So that will be negative 3x. Again, we subtract and we say over. So let me just clean this. Right, so that is cleared. So we see that here we can now subtract. So we say x squared minus x squared, that will be a 0. Then we have negative 5x. So we have a negative 5x minus negative 3x. So this will be positive. So that will be positive 3x. Then this will be negative 5x. So this will add up to give us negative 2x. So we can write negative 2x here. So again, the 6 doesn't have a constant counterpart it can subtract with. So we bring down the 6 here. So that will be a positive 6. So we put it here. Again, the algorithm continues. So what we'll do is we'll say, let me use black. So we say this x now into that variable there. So that is negative 2x divided by x. So we see that if we divide this, the x and the x will cancel and remain with negative 2 here. Then we can say negative 2 times everything here. So we're saying negative 2 times everything here. So we'll write that as, so negative 2 times x, that will be negative 2x. Then we say negative 2 times negative 3, so that will be positive 6. Again, we put in brackets, then we subtract. So again, we are doing the same thing that we did. So this is a negative 2x minus negative 2x, so that will give us a 0. Then positive 6 minus positive 6, that will give us a 0 again. So it's just as good as writing a 0 here. So we see that since, so what we write is this, we say there is no remainder here, we have a 0 down there. So let me just pull it up like that so you can see everything. All right, so we're going to say, let me use red. So here we say since this into this is equals to this, right? So we say since x minus 3 divide by, so put that in brackets, divide by this down here, which is 6x to the power 3 minus 17 x squared minus 5x plus 6 is equal to 6x squared plus x minus 2, which is what we have here, with no remainder, remainder, okay, with no remainder. Therefore, g of x, which is equals to x minus 3, is a factor of our f of x. And basically, if we get what is here and what is at the bottom there, when we multiply them, that is x minus 3 multiplied by 6x squared plus x minus 2, what we're going to get is what is inside here, which is just equal to f of x. So basically, that is the first part of the solution. Okay. Then we need to find the other factors. So we are also taught to find the other factors. So to find the other factors, we further need to factorize this part here, which is a polynomial, as you can see, which is quadratic expression. So this is quadratic expression. So we need to find solutions of this quadratic expression. Or let me say we need to factorize the quadratic expression. So how are we going to factorize the quadratic expression? So what we're going to do is the quadratic expression 6x squared plus x minus 2 as the product. To find the product, we say negative 2 times the coefficient of x squared. So that is negative 12. And the sum, which is equal to, the sum is equal to 1. Now, the factors of the product, 1 and 12. So when we say negative 1 plus or minus 12 plus or minus like that. So negative 1 and 12 can give us that. And we also have 4 and 3. Okay. So we're looking for factors such that when we add them, we're going to get a positive 1. And when we multiply them, we're going to get a negative 12. So basically, when we have 4 times negative 3, so this will give us negative 12, and 4 minus 3 will give us a positive 1. So basically, this right here can be written as 6x squared, we say, plus 4x minus 3x, then minus 2. And basically, the idea is that 4x minus 3x should give you x there, positive x. Okay, so after doing that, we see that we can factor out, between these two, we can factor out a 2x, so we can factor out a 2x here. So when we factor out a 2x, we're going to remain with that we factored out, we put it under 6, so there is 6 over 2. Then we're going to have 1x here, and the idea is that 2 and the 2 here can cancel out, and x times x will give us x squared. Then here we're going to have plus, when we factor out the 2x, we're going to remain with a 2. The idea is that 2 times 2 will give us 4, then x, which is 4x. And here we can factor out the 3, so that will be negative 3 out. Then if we factor out negative 3 here, we're going to remain with positive x. Then we say negative 2. So I'm teaching you how to factorize. So we'll say negative 2 divided by negative 3. So basically, that is the idea. So what you factor out, you just put it down here. So this simplifies to, even before anything else. So this is 2x out here. Then here we have, what is this? Okay, so we have what? So this is no, this was supposed to be factored out further. So let's do the refactorization so that we simplify things, so that we reduce the steps that we have to do. So here what you're going to do is you make sure that you factor out the coefficient that is there and the variable x. So let's factor out 6x. Then when we factor out 6x, we're going to remain with x. So the coefficient of x here should be 1. So we reduce the steps that we have to do. Then here we're just going to say plus 4 all over what we've factored out here, which is a 6. And the x there would have cancelled, so the x is out. So I'm just giving you an idea on how to do that. And here we factor out the entire coefficient of x here, which is -3. Then we say this will be x. Then we have a -2 here. Then we just say divide by what we factored out here, which is -3. So we just want to simplify things for us, so we reduce the steps. So here, let's simplify. So this is 6x. Then here that will be x plus, we know that the 2 can go there, which is 2. 2 can go there, 3. So this will give us 2 over 3. 2 over 3 minus 3 here. So this will give us x, a negative divided by negative, that will be positive 2 over 3 as well. So basically, we factor out this entire thing, and we're going to have x plus 2 over 3 factored out, and what we remain with here is 6x minus 3. Okay, so here the other factors x plus 2 over 3 and 6x minus 3. So these are the other two factors. So if we want, we can write this as x. We can factor out the 3 here. We can factor out the 3, or let me say we can factor out a 6 there, so that we have, when the 6 is factored out from this, we're going to remain with x minus 3 over 6. Okay, so basically on this part, then times x plus 2 over 3. Okay, then this can simplify to 6 outside. Then we have x minus 1 over 2 and x plus 2 over 3. So in total, the factors that we have in total, okay, let me just say the factors are 6x minus half, then and x plus 2 over 3 and x minus 3. So these are the 3 factors. So you're going to do the same for questions, I'll just name them question 2, 3, 4, and 5. So basically it's just the same idea. So you'll be dividing this into that, then this into that, this into that, and that into that. So I want to see the solutions. Then from there we use synthetic division to find or to show that some functions are factors of others. Right? So if you have any question, you can leave them in the comment section. But basically that is it. So the general idea is to show that this is a factor of that. We basically divide this into that, and if it leaves a remainder, then it is not a factor. But if it does not leave a remainder, we say it is a factor. All right, so try out these 4 questions that are here, then we see how we move on from there. Otherwise, it's a good night from me. Work well.